an engineer in Silicon Valley, and this is Pierre, my AI agent. Together, we're building Agent Flow Labs, a place where we show how practical AI systems actually work when they leave the demo stage and start doing real work. Not hype, not magic tricks, real architecture. In this video, Pierre and I are going to show you one of the most important design problems in agent systems. When should an AI agent spend the best model? And when should it delegate? We'll use OpenClaw as the case study. Because the question is not just what is the most powerful model? The better question is, when is the most powerful model worth spending? Most people building AI agents start with the obvious question, what is the best model? That question matters. But once an agent system is running every day, reading files, checking context, monitoring tasks, drafting, reviewing, escalating, and responding to humans, that question is not enough. If every task goes to the strongest model, the system may look smart in the moment and still fail operationally. A powerful model is not just intelligence. It is also quota, latency, cost, attention, and opportunity cost. Every low-leverage task you send to it is capacity you cannot use later for judgment. And judgment is the reason you wanted the premium model in the first place. An agent can be very capable and still spend its intelligence badly. The better mental model is simple. Premium model capacity is an operating budget. You do not spend the executive brain on every errand. You protect it for strategy, safety, final quality review, sensitive communication, ambiguous trade-offs, and decisions where being wrong is expensive. Everything else should earn its way to the premium model. So OpenClaw routing shifts the question. Not which model is best, but what level of intelligence should this task spend? The router looks at risk, ambiguity, whether the result is user-facing, current quota state, and whether final QA is needed. That is when model routing becomes architecture, not just cost-cutting. Model switching by itself is not enough. The useful part is the control layer. An agent system should know how much premium capacity remains, how fast it is being consumed, whether an urgent communication buffer is protected, and whether the current task deserves premium attention. The agent is not only responding to the task, it is responding to the task plus the resource state of the system. A practical system can use simple states. When capacity is healthy, the strongest model can plan and review. When capacity is moderate, preserve it for user-facing communication and higher-risk decisions. When capacity is low, workers and tools gather evidence. When capacity is critical, pause non-essential work and protect the buffer. This is not about being cheap. It is about preserving judgment for the moments when judgment matters. Delegation only helps if the handoff is inspectable. A useful worker handoff says what it checked, what files or sources it inspected, what commands or tests it ran, what changed, what remains uncertain, and what decision is needed. Otherwise, the premium model wastes capacity verifying the worker instead of making the decision. Workers are not captains. They are scouts. This is the core design pattern. Workers gather evidence, tools, verify state, and the premium model makes the final judgment when the stakes justify it. That is the quality gate. Without a quality gate, multi-agent systems become a pile of confident drafts pretending to be finished work. Which is not intelligence. It is just expensive noise. So here's the principle. Do not build agents that always use the best model. Build agents that know when the best model is worth spending. A serious AI system needs three things: a routing policy, a monitoring layer, and a quality gate. That is how practical agents move from impressive demos to reliable systems. That is what we are building at Agent Flow Labs. Together, we're exploring how useful AI systems are actually designed when they think, when they delegate, when they escalate, and when they stay quiet. If you're building or using AI agents that need to do real work, like subscribe and follow Agent Flow Labs for more flow theory.